how to fork threads in SystemC, just like in SystemVerilog and Specman-e. Before I talk about the presentation, a few words about myself. My name is Ștefan Tiberiu Petre. I'm located in Bucharest, Romania. I'm a hardware verification engineer with about 13 years of experience. My main expertise is in functional hardware verification, mostly with SystemVerilog and UVM, but I also have some experience with Specman-e and ERM, or the UVM-e library. And I've also worked on a few projects with SystemC, and I had to integrate SystemC reference models in multi-language verification environments. And in my spare time, when I don't do verification, I'm also interested in free and open source EDA tools, in simulation software, and sometimes machine learning. In this presentation, the main focus will be on dynamic thread creation. And by that, I mean the creation of new simulation threads after elaboration has finished, and usually at simulation times greater than or equal to 0. This is also known as forking. More specifically, I will first talk about how to fork threads in SystemC with what is currently supported in the current standard. Then how forking of threads is done in SystemVerilog and in the Specman-e languages. And then I will introduce a library that I wrote called SC Enhance, which kind of imports some constructs from SystemVerilog and Specman-e to SystemC, making it easier to fork threads. And then I will present a few use cases of these constructs. And I will also talk about some other features that I've added in SC Enhance, besides forking of threads, and then some conclusions, and then maybe we'll have a Q&A. So what's currently supported in SystemC for forking threads? The most basic operation you could do is to spawn a single thread and let it run in parallel with the parent thread, and don't do anything after that. And this is usually done with the SC spawn function, and you'll have to declare your thread function in advance, and then you're going to have to pass basically a pointer to this function to SC bind, which will create a handle that can be passable to SC spawn, and basically you can spawn threads that way. Also there are the SC fork and SC join macros, which allow you to spawn multiple threads, and then the parent can wait for all of them to finish before resuming. And yeah, SystemC basically gives a lot of flexibility here. Like, you can spawn simple void functions with no arguments, or functions which take arguments and return values. And you can also spawn global functions declared outside of an SC module, which take references as arguments, and you can use these macros to specify this and create a handle for SC spawn. Then if you're using modern C++, that means C++ 11 and later, you can also pass lambda expressions to SC spawn, and this makes it a bit easier to code the logic of your spawned threads. You don't have to declare in advance a function or a method and then pass pointers to SC bind. So this is a slight improvement. So all in all, at the moment, SystemC basically supports two types of forks. A join none, which means you just can fork as many threads as you want with calls to SC spawn, and the parent thread resumes immediately, doesn't have to wait for any of them to finish. And a join all, in which the parent waits for all of them to finish, and only then it resumes. Now, in other languages like SystemVerilog and Specman-e, there are more types of forks than just the two supported in SystemC, and I'm gonna take them one by one, and we'll see how they work. So the first one is fork join. So this is already supported by SystemC. As I said before, the parent spawns a number of child threads and does not resume until all of them have finished. And this is the syntax in SystemVerilog and Specman-e. In SystemVerilog, we have a fork join, and in Specman-e, it's this all of statement, which basically tells you that all of these actions have to finish until the main thread can continue execution. Then this is something that is not in SystemC. It's a join any join condition. That means the parent spawns a number of child threads and only waits for one of them. So it only takes one of them to finish, and the parent thread will resume, and the other ones will just continue execution in parallel. Then there is the first of, which is similar to join any, and this first of is only present in Specman-e, which does the same. The parent waits only for one child thread to finish and then resumes, but the difference is the other, once the parent resumes, the other child threads are terminated. They don't continue execution. And first off, even though it's not supported directly in SystemVerilog, you can do it with a workaround like this. You can use a join any followed by a disabled fork. A disabled fork basically terminates all the child threads of the parent thread, but we enclose this in a fork join because maybe the parent thread has previously spawned other threads which we don't want to terminate. So it's good to enclose it in this, and in this way you basically emulate what's supported in Specman-e, also in SystemVerilog. And then there is fork join none, which again it's also supported currently in SystemC. So in this way you just spawn multiple threads and you let them run, and the parent runs in parallel with them. There's no join condition in the parent after they are spawned. And in SystemC, of course, you can already do this with SC-spawn. You can call it multiple times to spawn multiple threads. And this is the syntax for SystemVerilog and for Specman-e. So to talk about disadvantages in the current SystemC support, I think what's currently supported is too verbose. I mean, there is a lot of flexibility offered there. Like when you call SC-spawn, you can pass spawn options to it, which can allows you to create very large variety of scenarios, but it can be too verbose. Sometimes you just want to do something simple and write very little code. There's no obvious support for join any, and when I say no obvious, I mean it's not impossible to create a join any scenario in SystemC right now, but you will probably have to write more code. You'll probably have to use events, like for example, at the end of each spawn thread, you could trigger an event, and then in the parent, you could wait for those events. You could create an event expression. So there are ways to do it, but they're not really obvious. And also, there's no obvious support for spawning multiple processes in a loop. I will talk more about this later. This is also something very important. It's also not obvious in SystemVerilog. It can be tricky to do, and used to be a problem in Specman-e, but recently some constructs have been added to address this. So how do we do it easier in SystemC? So I wrote this library. It's called SC Enhance, It's a header only library, which you include after you include the SystemC header. It uses modern C++, C++11 and later, and it's basically a collection of macros and classes meant to simplify the SystemC languages, and it could potentially be added to future SystemC standards. So first, let's see how we do a fork join. This, again, it's already supported, but in SC Enhance, I redefined these macros so that they, it's easier to, you don't have to call SC spawn for every fork that you spawn, or thread that you spawn, sorry. So what all you do is you define a list of lambda expression, one lambda for each thread. And that's pretty much it. You code the logic of your threads in line exactly where they are forked. You don't have to predefine a function or a method and then pass a pointer to SC bind and pass that to SC spawn. So it's more direct and easier to do. Behind the scenes, what it does is it starts a declaration of an array of function objects, and then you have to populate it by hand with the logic of your threads. And then the SC join macro simply closes that list, and it declares an SC join object, and then it calls SC spawn for each of these lambdas, and it creates handles, and then the join object is populated with these handles, and join has its wait function being called, and this basically is a time-consuming function and waits for all the threads to finish until it's resumed. So this is already supported. I just wrote an easier version of it. I think it's easier to code it like this. And of course, you also have the equivalent for clocked threads. You basically have the C fork and C join macros, and you have to pass the clock that is used by the clock threads. And pay attention that you should only use this macro inside a clocked thread. Don't try to spawn clocked threads from non-clocked ones, because it will not work. And I don't think it should work. I don't think it's meant to work like that. I tried it and I saw some strange behavior, and I didn't dig any further. I just don't think it should be done. Then there's the join any, which we saw in SystemVerilog. So it's very similar to the SystemVerilog syntax. You just use the SC join any macro, and you pass the lambdas. And again, what this does is it only waits for one of the spawn threads to finish, and then the parent resumes, and the other ones are just allowed to continue running. Behind the scenes, what it does, pretty similar to what I've shown you previously, declares an array of function objects. You populate it with lambda expressions, and then it uses a join any object. So this SC join any class, it's not present in SystemC. It's something I added in SC Enhance. And once you populate it with thread handles, the wait function only waits for one of the threads to finish. I can also, I think, show you a bit of the source code. So I think this is where so it's basically a copy paste of the SC join, and I just modified the signal function to detect only one thread when it finishes execution and not all of them. And also there's the equivalent for clocked threads. You can do a join any inside clock threads. You just have to pass the clock as argument to the cfork macro. And then we have the join first. This is what's supported in Specman-e, and it's just like join any, only that the once the first child thread finishes, the other ones are terminated. They're not allowed to continue execution. And behind the scenes, it's similar to join any. It does everything join any does, and also it kills all the other threads that have not finished. And also there's the version for clocked threads, as previously showed. And then there is join none. Even though you can do this with multiple calls to SC spawns, I thought it could be useful to have if you're porting code from SystemVerilog to SystemC, it could be easier to, and you want to automate it somehow. It could be useful to also have these macros, which they just spawn threads and let them run. The parent doesn't have any join condition on them. And yeah, behind the scenes, the same thing, declares an array, function objects, you populate it, and they are just spawned with calls to SC spawn. There's no join condition afterwards. And yeah, sorry, there's an error in the slide here. I meant SC join none. So you can also do this for clocked threads with SC join none. And then there's the problem with forking threads in a loop. Let's say you want to spawn not just 2 or 3, but 10 or 100 threads in your code, and you don't really want to copy paste the same logic 100 times. So it's easier to do it in a loop. And in SystemVerilog, we do it like this. Inside the fork, so usually you want to use the value of the loop variable, and in SystemVerilog you have to copy that value into a local automatic variable and pass that to the threads that you are forking, because otherwise if you pass I directly, there are going to be some race conditions and it will not work. And in SystemVerilog, there is only an obvious solution for join none. So you want to spawn n threads, but only with join none. If you want to do a join or a join any, or a join first in SystemVerilog, there's not an obvious solution. I'm sure it's not impossible, but you're probably going to need to use some events there and do some waits on those events after you spawn the threads. And in Specman-e, they've recently added these constructs, all of for each and first of for each, which basically allows you to spawn multiple threads and join them in various ways, either all of them or just the first one. And in SystemC, with SC enhance, you can also do this. All you have to do is declare a fork list. This is just a simple, very simple type def, which is a vector of function objects. And you populate this this list with lambdas in which you put your thread logic. And if you want to pass the loop variable, you give an argument to the lambda, and you will need to call scbind so that the argument, the I value, is applied as an argument to the lambda, and then you get a function handle for that. And once you have this list constructed, you have these macros: scfork join any, scfork join first, and scfork join none. And you pass the list as argument, and you can do any type of joins on all these threads once you have spawned them all. And I think this combines what's supported in SystemVerilog and what's supported in Specman-e, and I think from this perspective, SystemC becomes more flexible and powerful when you want to do something like this than SystemVerilog and Specman-e with these macros. Now I'm going to talk about some use cases, like what are these constructs useful for. SC-join, I'm going to talk mostly about verification use cases since I'm doing verification. One example use case is when you have a block that you're verifying and you want to drive or monitor multiple interfaces at the same time, because that block will definitely have more than one interface. So here's an example, SC-fork, SC-join. For example, you want to start an Ethernet traffic sequence on an Ethernet interface and some axis streaming, and so in parallel with that, monitor some signals. So these will run independently and in parallel, and the parent thread will wait for them all. And this is useful usually if you want to do something before this, like you want to do some configuration of registers, you want to drive a reset signal, you want to do something interesting before you call this fork, before you start driving the traffic. So once you're done with that, you drive the traffic. And another use case is when you have just one interface, but multiple data streams. Like, for example, you have one Ethernet interface, but you have multiple TCP IP connections running on that interface. And for that, you can also use SC-fork, SC-join. This is a UVM example here where you start two sequences on the same sequencer, and the sequencer will function as an arbiter, because both sequences will send transactions to that sequencer, and the sequencer will just take those transactions and drive them one by one. This is basically the reason why we have sequencers in UVM, in the UVM library, to be used in a scenario like this, where you fork two sequences and two or more sequences in parallel. Then we have some use cases for the join any. Join any, I haven't seen it used very often in verification, but when you do, you use it usually for a legal timeout. So in this example, we are spawning two threads. In one thread, we do something interesting, like we drive some transactions. Let's say we want to drive 10,000 transactions, and in another thread, we just wait some time. We consume some time, which is a timeout, and we do that because we don't want this thread to last more than 10 milliseconds, for example, or at least it doesn't have to in this case. If it does exceed this timeout, the parent thread will just continue execution, do something interesting afterwards, and it's gonna let this thread continue to drive its 10,000 transaction. It's not gonna terminate it or shout an error. And another use case, a horse race simulation, or let's say you want to simulate a process that resembles a horse race. In a horse race, when the first horse passes the finish line, you can consider the race to be over, because you know who the winner is, but at the same time, you don't want to stop the other horses. You want to let them finish as well, so you can find out who's on second place and third place. So when you have a process that resembles something like this, join any can be useful in that situation. Then for join first, you can use it for illegal timeouts. So as in the previous slide, you have two threads. One of them waits for a timeout, only that this time, if the main thread that does something interesting takes too much time, then that can be considered as an error, and you don't want to let it continue. So once the timeout has expired, you shout an error and you terminate that process. And either you stop the simulation or you continue doing something else. And another use case is reset handling. It's used a lot in verification. So let's say you have a monitor component which collects transactions from an interface. But if the reset signal is asserted, you have to stop collecting transactions, and that can be done in the join first. And what I usually do, I wait for the first reset in the simulation, and then I start a forever loop where I wait for reset in parallel with collecting transactions, and every time a reset appears, it kills the collect transactions thread, and the loop starts over, spawns again the two threads in parallel. One second, let me look at the time. Okay. For join none, the most obvious use case, you just want to spawn a thread and not care about it, but another interesting use case would be atypical join conditions. That means you spawn multiple threads, you want to have a join condition on them, but not the ones that I've presented before. You don't want to do a join, you don't want to do a join any or a join first. You want to do something else more elaborate, more sophisticated. And in this example, let's say you spawn three threads. At the end of each thread, you emit an event to notify that it has finished. And then you can code the join conditions as an event expression, for example, or some other way. So join none, I guess it's the default way to spawn threads and make up your own join condition. Another interesting use case is temporal expressions, or as they are called in SystemVerilog, they're called sequences. Let's say we have this example, we want to detect this behavior. So we have 3 events, X, Y, Z, and we want to detect a situation where Z occurs within N1 to N2 cycles after either X or Y occurs. Okay. Now I noticed there is already some work done on supporting assertions in SystemC. But if you want to code the logic of an assertion or something like this using procedural code, you don't like declarative code for some reason, you can use forks. So in this situation, first we want to see whether X or Y occurs, and we can use the join first for that, where we spawn 2 threads to wait for X and Y, and this join finishes when either X or Y occurs. And then we use another join first, where we wait for Z in one thread, and in the other one we want to detect this part, N to N1 to N2 clock cycles. So how do we find out if N1 to N2 clock cycles have passed? I think you can wait for the maximum number of cycles, and you can increment the counter. And once that is done, you just check the condition, whether the number of clock cycles is between N1 and N2, and if Z has occurred. And if this condition is satisfied, then you have another event that the sequence has been detected, and you notify it, and other threads, other processes can hook up to this event and do something interesting when it happens. So you can use forks to code temporal expressions procedurally. And for spawning threads in a loop, I think the most common use case is when you have a block with a parameterizable number of identical interfaces. Like for example, an Ethernet switch, which has multiple Ethernet interfaces. They are all identical. They have the same signals, the same protocol. And you want to drive traffic on each one of them independently. And if the number of interfaces is too large, it's easy to do it in a for loop. And you populate it with some threads that, for example, start a UVM sequence on a sequencer. And then you can join these threads however you find useful in your scenario. Now I'm going to talk a bit about other features that I've added in SC Enhance, and one of them is simplified process declaration. So right now in SystemC, if you want to declare an SC method or an SC thread, you first have to declare a method, function inside the SC module, and then in the constructor you have to register it as an SC method, and also in the constructor you have to define the sensitivity lists if you need one. And the fact that there is this separation between declaring the body of the method or the thread, and then later on in the constructor you have to register it and declare the sensitivity list, I think it can be a source of distraction and bugs, because you have the code split into multiple places, and you might forget, for example, to define the sensitivity list or to simply register it as an SC method or an SC thread, and you're gonna wonder why is it not running when you start the simulation. So I think it would be sometimes easier to put all of these parts in the same place, declaration, sensitivity list, and the body, put them all in the same place. And you can use these macros, SC method declare, SC method begin, SC method end. And you can do this in the body of the SystemC module. So this is a declarative construct. You don't have to do it in the constructor or in a function. You can do it in the body of the SystemC module. And the same for threads. Like if you want to do a don't initialize, you can also do it here where you do the sensitivity list. And also for clocked threads, you can use similar macros, and you have to pass the clock event as an argument. Other features, simplified constructors. So what I noticed in SystemC, when you define the constructor of an SC module, you have to pass it an SC module name argument, and then you have to call the constructor of SC module and forward that argument name to it. And this is verbose, and it can be tedious to write it by hand all the time, and it might be easier to just have a macro that does that behind the scenes. And you might also want to have constructors that take arguments, and you can use the same scconst macro, which is a variadic macro. It can take a variable number of arguments and forward them to the constructor. And if you want to just declare the prototype for the constructor and implement it outside of the class externally, like when you want to separate your header from your source file, you can use this scconst empty, which just declares the prototype, and then in the source file you use scconst implement, and you can also take a variable number of arguments. So that's another thing. And then I also added a few macros for simplified signal and instance declarations. These are not something revolutionary, but I think it's a good idea to use macros like this when you declare signals and instances, because you usually want the name of the signal variable to also be the same as the name string that that object has. So to avoid introducing typos, it could be useful to use these macros, which basically expand to these declarations. And another feature is simplified port connections. So currently in SystemC, we connect the ports in the constructor of the SC module, but with these macros, connect ports begin, connect ports end, you can add port connections anywhere you want in the SC module. So for example, here you instantiate your DUT, your block, and you want to connect some test bench signals to it, you can do it immediately after you have declared it using these macros. So that's another thing that can simplify the language. I think I missed a slide here. I also wanted to, I think by mistake I removed the slide, to talk about method ports. I think I'll show you some code. So method ports, they are like TLM sockets. Okay, they forward method calls from one process to another, or from one module to another. Okay, the only difference is that with the method ports from SC Enhance, you are not constrained to use a specific method signature. Like TLM sockets constrain you to just call a function that takes a generic payload as argument and maybe a delay there. But that's it. That's the only type of method call that you can forward. While while method ports in SC Enhance allow you to call any type of method with any number of arguments of any type and any return type. And some examples. This is how you declare a out method port. So this is a port that's used to send out a method call, and when you use it, you just call it as a normal function. So when you declare it, you give it a name and a signature, like what types of arguments it takes and what it returns, and then you just call it as a ordinary function. And then you have in method ports. So these method ports, they are usually connected to out method ports, and these are like the implementation ports in TLM, and they execute what you define as their body when the method port is called. And the same, you provide a name, type signature, and also a lambda where you describe what it does when it's being called. These are very similar to function objects, but behind the scenes, they also do some connectivity checks, and they build a small database of connections that you can query if you want to debug them. So that's the difference between method ports and just using C++ function objects. Okay, going back here. Standard support. So all the features in SC Enhance support C++, 11, and later. I have tested them with these three, except for method ports, which I couldn't get them to work with C++ 11 because there is a function or a language construct called declaration DECL type, which is not supported in C++ 11. And without that, you cannot customize the return type of a method port. Another thing to watch out for is putting breakpoints in lambdas. So pretty much all the constructs that I've shown you until now, they use lambda expressions. Even the forks, you have to use lambda expressions. And what I noticed, if I put a breakpoint inside the lambda expression when I use the GNU debugger, and I start to step, something strange happens. It jumps at the beginning of the lambda and then jumps at the next line, and then again jumps at the beginning and then at the next line, which it was very confusing. And I found out that if you give this flag minus OG, that's going to be fixed. So you can step normally through the lines of a lambda. A few words about potential incorporation into the SystemC standard. So at the moment, SC Enhance is made up of 3 header files. The main one is SC Enhance HPP, which includes most of the logic. And the other 2 headers, method ports, includes the logic for method ports, and SC thread process.h. This is basically a copy of the file with the same name from the SystemC library, and I had to modify it so that the SC join any object that I've added in SC Enhance can have access to can be declared as a friend class for the SC thread process class. I noticed it doesn't work if I don't do that, so I had to redefine, re-include this file and with some slight modifications. Incorporation in the SystemC library, I think it can be done in one of the following ways. You can just copy these headers, add them to the SystemC library, which is probably not the most elegant way. And also you have to replace the SC thread process with my version of it. Or you can just split these headers into multiple ones depending on what features you want to import. Or you can just copy paste the code from these headers into the existing header files in SystemC, and you don't have to add any extra header files. So that's up for discussion, I guess. For the standard, I think section 5.2 might need some extra documentation for simplified process declaration and simplified constructors and simplified signal instance and connections. And in section 5.5, some extra documentations for the new types of SC fork that I've proposed, and maybe add an extra chapter for method ports. Potential issues, SC fork and SC join have been redefined by SC Enhance, so could cause some potential backward compatibility issues. And something to watch out for, the method ports are not thread safe, so you'll have to use SystemC mutexes if you expect race conditions when using method ports. Some conclusions. So SC Enhance gives you a more versatile way of forking threads by importing features from SystemVerilog and Specman-e, and even overcoming some limitations that are present in SystemVerilog and Specman-e. And in my opinion, I think it makes SystemC a more powerful language. Using features from modern C++ obviously can make code more concise, more readable, easier to write. And SC Enhance can be incorporated into the SystemC library either as is or slightly modified for backward compatibility. Simplified method declaration, like SC method declare, can make it easier to write RTL code in SystemC, for example, and method ports can make it easier to write, TLM models or SVPs, both loosely timed and approximately timed. Since you get to choose what arguments get passed and what values are returned, you have a lot of flexibility to define transaction level models. As bibliography, obviously the standards for SystemC and SystemVerilog and E, and I've also watched some tutorials and some threads from the Etc forum where it was previously discussed how to do a fork join any, or to do similar forks as in SystemVerilog. And if you want to contact me after this on GitHub, I'm a verification contractor. This is my LinkedIn profile, and this is my email address. And I think this concludes my presentation.
Thanks a lot. Interesting to hear. Let's see where we are with everything. It's 9:45. We have time for questions. As you can see, Stefan, you have people have already started to ask questions and also answer them. But if we start with the chat, we have from Julian here, why is SEC Tor MyMod 2? I guess a typo, he says.
Yeah, 1 second. I'm gonna scroll up. Yeah, there might have been some typos.
Hang on, I will share my screen so you can
Okay, CTOR. I think there isn't there. I might be mistaken, but isn't there a macro in SystemC for declaring a constructor which is named CTOR?
Julian, you might want to comment or clarify. If you can speak.
Maybe what is difficult is that the comments were kind of live on a specific slide, and we don't really now remember what was the slide at that time. Maybe what you could possibly do is try to share again the presentation, yeah, and for the people who made the comments and confirm which slide was the one.
I think it was this
that
one.
Triggered the comment, maybe.
Yes, CTOR. I don't know. Isn't it in the already in the?
Hi. He says it's slide 18 in chat.
Slide 18.
18. Okay.
Yeah, the question is why is there number 2 there?
Okay. Wait, sorry. Yeah. It's a typo. Apologies for that. It was supposed to be my mod. Yeah, the main focus was the fork, but yeah, I probably forgot that. Sorry about that. I'll correct it when I send the slides.
Okay, let's see if we can see the other questions here. There was from Kartik about class constructor or function to fork join. Can you see the question, Stefan?
1 second.
From 922.
Is it okay if this is Karthik, is it okay if I go ahead and ask?
Could normal functions be used inside the SC fork and SC join instead of Lambda? With SC enhance, I think it should be possible to pass function pointers. What I had in mind was to use only function objects or Lambda expressions. But I think if you somehow cast your function pointer to a function object, I think it can be done automatically. You can probably do that as well. I haven't tried that, to be honest, because I wanted this to be a simplified version of SC fork, SC join, where you only use lambdas, because it's easier to do like that. But I think it's not impossible to pass function pointers to it.
Okay, then we had a question on SC repeat, if it should be small letters or capital letters.
Yeah, that's something I forgot to add in the presentation. It's a macro that is also in SC enhance. It's small letters, lowercase, and it's similar to the repeat in SystemVerilog. It's just a loop behind the scenes, a for loop that iterates from 0 to whatever value you give to it. So it's not something big, but can be useful to write smaller code.
And then there is this, yeah.
I guess it's a good idea to use SC repeat with capitals to make it known as a macro. Really. Would scconst macro work even if the user wishes to provide a initializer list? Okay, yeah. I don't think I've tried that. It's a good idea. But I don't see why not, because the scconst macro, it's a variadic macro, so it's just gonna forward all the arguments blindly to the constructor. So if you also initialize each argument, the initialization itself should be forwarded as well. So I don't see why it wouldn't work. This looks like already done proposals. SC named.
Perhaps you can clarify, Jerome, about this
Yeah,
one?
it was just to say that the small macros you presented that intend to for the user to avoid repeating the identifier as a string to provide the SC module name.
Yeah.
Are already part of a proposal of enhancement of SystemC that is examined or has been examined in IEEE in the current IEEE revision. So
Okay.
we are working on it.
Okay, it's good that it's already there.
It's not exactly the same syntax, but the idea is the same.
Okay.
Maybe since I'm talking, I can jeopardize a little bit and ask a question on this SC method port. I'm not sure to have understood exactly what was the how it
Yes.
worked, and maybe just some people may have understood better than me. So just for everyone to be, you had a remark that it was not thread safe. So if at the same time you can explain why is there any thread safety here? But maybe this is related to the file. I did not really understood what method port are. What is the proposal?
Yes, of course, I can try to elaborate on that. So method ports, they are actually a feature from the Specman-e language. So you can look in the Specman-e standard for more info on that. It's really simple. Like they are like ports that propagate method calls. And as I said, they are similar to TLM simple sockets, where you have the B transport function, and in the producer, producer module, you call that B transport function, and in the consumer, you have to implement it. And from a higher level, you have to connect these sockets together, and that way the B transport call gets propagated from the producer to the consumer. That's pretty much what method ports do, only that they are a generalization of TLM sockets, meaning that you're not constrained to one type of method call, like the B transport, which takes a generic payload as argument and I think a delay reference. I think it was like that. You're not constrained to just that type of method call. You can propagate any type of method call with any arguments of any type and any return value.
Okay, so maybe this is more flexible because actually the TLM sockets, they are based on a generic mechanism, which is the mechanism of SC port and SC interfaces. So basically at the core of this thing, there is already a generic mechanism.
Yes. Method ports are more simplistic. They're not based on that behind the scenes. They're just basically wrappers around the function objects, and they do some connectivity checking, but they don't interact with the SystemC kernel that much. So they're not aware of SystemC threads or events or time consumption, which is why I mentioned that they're not thread safe. And for example, if you call multiple out method ports and they all manipulate the same resource from multiple SC threads, you might want to put use some SC mutexes, some locks every time that resource is accessed, so that you don't have any weird race conditions that you won't be able to explain. No.
Okay, yeah, this is kind of the same as if you would be doing a TLM2B transport call to the same target from multiple threads, and potentially you would have a shared resource. So this is the same kind of problems, I guess.
Yeah. Yeah, I'm not sure if there's any thread safety done behind the scenes in TLM2. I don't.
No, I mean, SystemC itself is still single-threaded, right?
Yeah, I was talking about SystemC threads, not OS threads, like simulated.
Exactly. So I don't think you would actually, you wouldn't get the typical race conditions. You would still need to consider.
Actually, if you have two transactors, for example, going through a router accessing the same source, and the source has a wait in the blocking call, you might get here a race condition. And there you need to work with SC mutexes to ensure that they are serialized because you have shared variables.
Yeah, exactly. Actually, what is called race condition here is the fact that depending on the order of the scheduling of the various processes, the various threads, you could get different results.
Yeah.
Which is a little bit different than the thread safety in a thread context.
Yeah, it's not true thread safety. It's more make sure you don't call into something that's already blocking, essentially. So it's more locking discipline or.
Yeah, but if you employ this notion of a thread, an SC thread, then it's thread safety with respect to the SC thread, not to the OS threads. From that perspective, Petre was totally right.
Yeah, it's a thread safety in a coroutine or cooperative context.
Yeah, right.
Yeah.
But in the context of systems.
I agree.
Maybe if I can, I have so thanks first for this nice presentation. I have just one remark as a IEEE chair for SystemC. I think what makes the success, there was in your slide the question of, okay, how do we integrate this in SystemC? And I'm glad that you both presented the code part, but also the language reference manual part. And just to make a small comment on this, one of the most important thing when you want to do a proposal and when you want it to be integrated and to ease this integration is to have a small document, a PDF file, for instance, that would potentially looks like a little bit like the LRM, and that would describe what exactly is the behavior of the various constructs you are proposing. We've got a nice example of a past example of a successful example of this is for the SC vector. The proposal for SC vector, it was done by Philippe Hartmann. Many of you know him. And it was a combined, it was done with a PDF file as well. And what I remember for the 2011 revision of the norm is that basically we did not really spend too much time on it. It was integrated very quickly because of that document. So if I have a small advice to you is, if you've got that document, or if you don't, please do it. That would ease the integration process. Right now, for instance, in IEEE, the problem we've got on several proposals that are very valuable is that sometimes we are multiple people trying to just retrieve what was the original intent, because all that we've got is basically the code with some comments in the Accelera kernel, and that is not enough for proper integration in SystemC.
I understand. Yes, I will try to produce such document. And I think I've seen that SC vector proposal you're talking about, and I can use it as an example.
Okay, and thanks again.
Thank you.
Yes, thanks a lot. It's 10 o'clock.
Oh, okay. I guess.
Perhaps there was some final question. I think Jakob asked about if it's basically for test benches, and I think that the use cases you had were verification oriented, and you said that as well, right?
Yes, but I think these constructs can also be useful in modeling. especially method ports, like for sure, I think they can be used. And,
I mean, but I'm a thread skeptic, right? I want performance. I don't want threads. They get in the way, but I can definitely see the use case for outside stimulus when you have pseudo parallel things going on. But that's modeling philosophy, not for now. Now it's time for the next talk.
Yes, let's do that.